A very good morning to all the students. I hope every one of you is fine and in your best health. We were doing chapter number 4, that is carbon and its compound, and in the continuation with the topic, today we'll study the homologous series. Now, homologous series is a series or a group of organic compounds which have similar structural formula, same functional groups, and therefore they have similar chemical properties. So the members of homologous series are called as homologues and the phenomena is called as homology. So the definition would be a homologous series is the group of organic compounds having similar structure and similar chemical properties so in this the upcoming compounds which comes afterwards, because it is a series, so one after the another there will be carbon compounds or hydrocarbons. So in this, in which the upcoming or the successive compounds, we will discuss with this as well. Compounds differ by Ch2 groups. Okay, so this means that this is a series in which the organic compounds which have similar structural formula and same functional group, and therefore they have a similar chemical properties. Because they have similar chemical properties, so they are placed in a homologous series. So as we know that all the elements having the similar electron structures show similar chemical properties that we have studied. So when we see them in the periodic table, so we find them that they are placed in a same group. So likewise, this is a homologous series. So all the compounds or the organic compounds which have same structural formula and same properties are placed in a series which is called as a homologous series. So I'll tell you an example of this. So all the alkanes have similar structure and with a single covalent bond, because when we say alkane, so all the compounds have a kind of a similar structure, only they differ by CH2 group. Like as we will say about methane, okay, ethane, then propane, butane, pentane, and I can write for a long time, but I'll stop here. So in this we see that though the structure, all those structure have a similar structure because they all have single covalent bond and they show similar chemical properties. Like all these alkanes, methane, ethane, propane, will show the similar chemical properties, and therefore they can be grouped together to form a homologous series. So the first 5 members of this homologous series of alkanes are written here, and they have a general formula. So, and we have already studied that the general formula of alkanes is CnH2n plus 2. So where n is the number of carbon atoms. So as if I'll write the molecular formula of methane, it will be CH4, and ethane it's C2H6, propane it will be C3 H8. Now how I am writing this formula is that because I've written the general formula CnH2n plus 2, we have done this before also. When n is the number of carbon atom, like C is 1, so C1, so H2n. 2n means 2 into 1, so it will be 2 plus 2. So 2 plus 2, 4. So that therefore is H4. And then when C is 2, so here C2, H2n. So 2 into n means 4, 4 plus 2, 6. So C2, H6. So this is how we will write the formula. So C4, H10, because C4. So n is the number of carbon atoms, so n will be here also. So C4H2 into n, 8 plus 8, sorry, 2 into n, 8, and then plus 2, 10. So it will be 10 here, and C5, it will be 12. Okay, so that means every other this organic compound hydrocarbon, or we can say every hydrocarbon, so the successive numbers, so 1 2 3 4 5, so they are having a difference of CH2 group, like 1 C is added, so 2H is added, and then 1 C is again added, so 2H is added. 6 plus 2, 8, and then 8 plus 2, 10, and 10 plus 2, 12. So every successive hydrocarbons are having a difference of CH2 group. So that is the character of homologous series. So there are a lot of characters in the homologous series which we will be doing it, and if we will split it, we can also see this can be done like this, C, and it will be okay, H4. So here, and this one is C, and then H6, and so on. We can do this. Okay, so likewise it happens with all the other alkanes, alkenes, and alkynes. This is we are doing for alkanes. Okay, so the homologous series for alkene will also be same like this. So alkene have, this is for alkane, so alkene have a general formula of CnH2n only, and alkyne have the general formula of CnH2n minus 2. So again, alkene are those compounds which have double bond. Okay, so in the alkene it's double bond, and alkyne it's triple bond. So that is why they come in the homologous series, because they will have a general formula, same general formula. And the first 5 members I'll write here, like ethene, then propene. Why don't we write here methane? Because it has to be double bond, and single C cannot make double bond. Okay, so they have to be 2 C's to make double bond. So propene, butene, pentene, and hexene. Okay, so for ethene first, it will be CnH2n. So if C is 2, so H will be 2 into 2, so it will be 4. So it will be C2H4. Then C is 3, so H will be 6, because 2n. When C is 4, so H is 8, and when C is 5, H is 10, and when C is 6, H is 12. So here also we can see, so every successive hydrocarbons in this homologous series of alkene will have a difference of CH2. So when C is 2, so H is 4. When C is 3, H is 6. So again, a difference of, we can see here all, the difference is of CH2. 1 carbon and 2 hydrogen difference is there in all the successive hydrocarbons in a homologous series of alkene. And again, the same will happen in the case of alkynes also. So the general formula of alkyne is CnH2n minus 2. So I have asked you to learn this in our previous lecture. I hope you have done it, and you haven't, so you have to do it, because it will help you this chapter is deleted. A lot of topics of this chapter has been deleted, which were very important. So the difficult portion, I must say, the difficult portion of this chapter is deleted. So only these things are left. So you have to be very, very careful about these things. So these things will surely come in the exams, because nothing is left in the chapter which will say difficult. So again, for the alkyne, they have a triple bond, and I'll write some first 5 hydrocarbons or members of this alkene homologous series. So it will be ethane, okay, propyne, butane, pentane, and hexane. Okay, so the formula will be C2, and C is N, so N is 2, so H is 2N minus 2, so 2 into N means 2 to the 4, so minus 2 will be 2. Okay, so C2H2, next will be C3H4, and then next is C4H6, then next is C5H8, and then C6H10. So again, there is a difference of CH2. So it was a character which we have studied, that every successive here, that with the successive compound differ by CH2 group. So that is a homologous series. So a homologous series is a group of organic compound having similar structures and similar chemical properties in which the successive compound differ by CH2 group. Okay, so we will be doing some characters of homologous series. So the characters of homologous series are, you have to learn these characters. Sometimes it happens in the board exams that you students are being asked to write the characters, and it can come in the other type of questions as well. Homologous series. So I'm just writing a short S here. Okay, so number 1 character of a homologous series will be that all the members of a homologous series can be represented by same general formula that we know. So first character is that each homologous series has a general formula. Okay, so all the members of a homologous series, because the name is telling us homo means same, homologous series has same general formula. Okay, so for example, alkane has a formula of CnH2n plus 2, alkene has CnH2n, and alkyne has CnH2n minus 2. Okay, so this is the first characteristics, and the second one is any two adjacent homologous differ by 1 carbon atom and 2 hydrogen atom, that is they differ by CH2 group. Okay, so any two adjacent members of a homologous series differ by CH2 unit in their molecular formula. Okay, so that means it will differ with 1C, 1 carbon atom, and 2 hydrogen atom. Okay, this is the second character. Now third will be the difference in the molecular masses of any two adjacent homologous series is 14U. So we have done this in class 9th, that a molecular mass, so there will be a molecular mass difference of fixed 14U between the two adjacent adjacent members of a homologous series. So the molecular masses of two adjacent homologues because the in the beginning we have read that the members of a homologous series are called as homologues, and this phenomena is called as homology. So the molecular masses of two adjacent homologues differ by 14U. Okay, so that means that for example, the molecular mass of, let's say, the molecular mass of methane is like Ch-4. So it will be, the molecular mass of methane will be carbon is 12 and it's 4, so it's 16U. Okay, so the next will be what? Ethane. So ethane's formula is C2H6. So we'll count it, 12 into 2 plus 6, it will be 24 plus 6, 30. So now 30U. So 30 minus 16 will be 14. That means the difference is 14U, and you can solve for the other as well. So between the every adjacent homologues there will be the difference of molecular mass of 14U. So I will write here homologues. What are homologues? Homologues or homologues, and homology. Okay, so members of homologous series, and phenomena is called as, okay, fine. So this is done. So now 3 characters we have done. So the next will be the members of a homologous series can be prepared by a similar method of preparation. That is, they have a general method of preparation, so that's not in our syllabus, so we'll not do that. So the next will do that. All the compounds of a homologous series show similar chemical properties. All the compounds of a homologous series show similar chemical properties. Okay, so like in a homologous series of alkane, methane, ethane, propane will undergo the same substitution reactions, so they will show the same chemical property. And the next will be the homologous, in the members of the homologous series will have a gradual change in their physical property, so they will have a same physical property as well. So the next point, it will be the physical property of the member of a homologous series changes gradually with the increase in the molecular mass. That is, the physical properties will change gradually, like physical states of density, melting points, and boiling point will increase as the complexity of the compound will increase. Okay, and the next is that all the members have same functional group, same functional group. So we don't have to study functional group here in this chapter for this year. Okay, so these are some characters of the homologous series. So better you learn these characters, that will help you and they might come in exam. So this was all about a homologous series. Okay, so I hope it's clear. So after this you will be doing some question and answers and you have to make notes for this. It will be very beneficial for you if you make it, and you'll surely make it. Okay, so please study hard and take care of yourself and do your work in time. Thank you.